the y-axis so that its velocity at any time is t greater than or equal to 0 is given by v t equals t cosine t. A, for what values of t on interval 0 less than or greater than t less than or greater than 5 is the particle moving upward?
So for the particle to be moving upward, so we have particle velocity and acceleration. If it is going up, then the velocity is what? Positive. So we know our velocity must be positive. The cool thing is, this is your velocity already, so you don't have to do any derivative or any of that. So let's go ahead and set that equal to 0 first of all. Let's make our number line. They already gave us our endpoints are going to be 0 to 5. So if I set the velocity equal to 0, the first one that's going to give me is going to be t is equal to 0. But don't we already have that as my critical point by the given? So that part is not really helpful. The next part is going to be helpful. Cosine of t is equal to 0. Okay, let's make our x and y axes. And I need to figure out where's my cosine movement 0. Meaning, when do I not go left or right? How many positions do I have? Isn't that one of them and that one of them? So we know this is at pi over 2. This down here is 3 pi over 2. So we know our critical numbers here is pi over 2 and 3 pi over 2. So let's make 2 tick marks right here. But we have to test the numbers in between, and let's be clever about what to pick. Because I want to use something with pi over 6, pi over 3, and so on, why not test pi over 6? What number is clever for us to test right in between on that one? Pi, good. What about in between right here? 2 pi? Let's do it. No, 2 pi wouldn't work, right? No. Oh, that's not nice, because 2 pi is going to be over 5.
What?
Let's get rid of that.
Oh, yeah, okay.
So that's not within the range.
3 pi over 2
Could we do it maybe like 5 pi over 3? Would 5 pi over 3 work?
Yeah, should.
You're like, I trust you. All right. And then when we're plugging it in, we're going back into this right here. So I need to figure out is it a positive or a negative. And I'm going to go about the easiest way possible. Y'all ready? Because I don't care about the actual number. I'm just going to worry about is it a positive number or a negative number. So when I plug in pi over 6 into this t, it is positive. Pi over 6 is about right here. Is my x coordinate of this point right here positive or negative?
Positive.
So we know that cosine is going to be positive as well. So we know this one is positive, so my graph is increasing. Now if I test it at pi we have -1, 0.
Wait, what? Oh, yeah, okay.
And now we're plugging in the pi into this guy right here. Pi is positive. And cosine of pi is going to give us -1. Positive times a negative is negative, so it's going down. I should circle that. Now 5 pi over 3 is going to be somewhere over here, right?
Right.
Is the cosine movement here positive or negative? Positive, so we have positive times a positive is positive, it is increasing. And the question asked us, where is a particle moving upward? And we have 2 intervals, 0 to pi over 2, union, 3 pi over 2 to 5, and boom. Okay, part B. Luca, let's read.
Write an expression for the acceleration of the particle in terms of t.
Okay, so right now we know the velocity. I'm asking you for the acceleration. So we need to find the derivative. So let's underline acceleration and write this as a slope of the velocity, or just find the derivative. So we have a of t. What rule are we going to use on this one? Something times something. Product rule, thank you. So derivative of t is 1. You keep the second piece as it is. Plus, you keep the first piece t. And when I derive the cosine, that gives me what?
Cosine of 1.
Ooh. Derivative of cosine is?
Right.
negative sign. And if I were to rewrite this just because it looks like I have a minus instead of a negative, you could say cosine of t plus, oh, not plus, minus, silly, minus t times sine of t. And they're still equivalent. Okay, any questions on number 1? Okay, all right. For number 2, Maya, let's read 2 and part A.
A particle moves along the y-axis with the velocity given by vt equals t sine where t is greater than or equal to 0. In which direction, up or down, is the particle moving at the time t equals 1.5?
So we're trying to figure out, is it going up or down? The particle's going up if the velocity is positive. It's going down if the velocity is negative. Don't we have the velocity function already? So you do nothing with that. So let's write on here, velocity must be positive if it's going up. It must be negative if it's going down. So all we need to do is plug this t value into our domain. So let's write v of 1.5 is equal to, the equation says 1.5 times sine of 1.5 squared. And we're not squaring the sign, but just inside the parentheses. Okay, I'm going to use a calculator for this piece. So we have 1.5 times sine of 1.5 all squared inside. Okay, do I have a positive or a negative number?
Positive.
Positive. So we know this is positive. So is the particle going up or down? It is going up because the velocity is doing what? It's positive. Okay, let's go on to part B. Alex, let's read part B.
Find the acceleration of the particle at time t equals 1.5. The velocity of the particle increasing at t equals 1.5. Why or why not?
So acceleration is the slope of the velocity. So do I need to derive the original function? Yes, we do. So let's write out a sub t is equal to, again, that's product rule. So we derive the first piece, which is 1, keep the second piece as it is, plus keep the first. For the next one, do y'all see chain rule? Okay, what is the derivative of sine? Cosine, and you keep the inside as it is. And then you derive the inside. T squared derivative is 2t. Now let's plug in the 1.5. So a of 1.5 is equal to, we have sine of 1.5 squared plus 1.5 cosine of 1.5 squared times 2 times 1.5. And I'm going to type that in. And y'all type with me. Ooh, no, 5. Cosine. Times. I see a lot of you guys like calculating in your head. Must be nice. Mitchell, was it a positive or a negative number? No. It was a negative 2 point something. So it was about
yeah, okay.
negative 2.049.
That's what you calculated, said,
So is it increasing?
no.
Particle is decreasing, so I'm gonna write no. Velocity is decreasing because acceleration at 1.5 is negative. Right, Mitchell? Not positive? All right, Luke, let's read part C.
Is the particle speeding up or slowing down at time t equals 1.5?
Okay, at time t equals 1.5. So we know our velocity was something and acceleration was something. In this piece, I didn't really teach you guys yet, but I'm gonna go ahead and kind of give you the information. At t equals 1.5, my acceleration is negative, right?
Right.
And velocity at 1.5 is positive. So I'm kind of pre-teaching. If your velocity and acceleration has opposite sign, it is always slowing down.
Right.
So let's write slowing
Oh, yeah, okay.
down because v of 1.5 and a of 1.5, they have opposite signs. Okay, let's go over number 3. So if any, this part might be a little confusing because I didn't really teach that part yet, but I will like in 5 minutes. All right, let's go over number 3. Hayden, let's read. Hayden.
The table gives selected values of the velocity v of t of a particle moving along the x-axis. Name everything this tells you about the particle's motion and select the graph of the position x of t.
We're gonna just select the graph, okay, if you're okay with it. First of all, it's saying at t equals 0, my slope is negative. My slope is negative. So at t equals 0 on A, is that going down?
No.
Nope. What about B?
No.
It is below the x-axis, but it's not physically going down. Okay? What about C?
Yeah.
Ever so slightly. Y'all see a little gap there?
Yep.
Okay? And then what about D?
No.
Nope. What about E?
Yes.
Okay, so we're good with that one. And then it says at 1, my slope is going to be pretty sharp. So at 1, my slope is going up. And then at 1, is my slope going up at all here?
No.
What is my slope right here?
Horizontal.
Horizontal tangent is going to be 0. So we know our answer has to be, boom, C. If you want to analyze the whole thing, go for it, but I think that's enough. All right, for number 4. Let's see. Ashlyn, let's read.
A particle moves along a straight line. The graph is the particle's position x of t at time t, where above for 0 is less than 2 and less than 6. The graph has horizontal tangents at t equals 1 and t equals 5, and a point of inflection x equals 2. What values of t is the velocity of the particle increasing?
So I want to know when the velocity is increasing. So I'm going to go to my card because we use this every day. Velocity is increasing when I have what kind of concavity? Concave up. Do I see a concave up right here? And that is between 0 and 2. So that's got to be A. Done. Pretty simple. Okay, now let's go to number 5. Okay, on number 5, Gordon, let's read.
A particle moves on the x-axis with velocity by v of t equals 3t to the 4th minus 11t squared plus 9t minus 2. For negative 3 is less than or equal to t is less than or equal to 3. How many times does the particle change direction as t increases from negative 3 to 3?
So let's underline the particle is changing direction. So going back to my card, eyes on the board. The particle is changing direction when the velocity is doing what? Changing signs. So what I would do is actually graph the velocity. And when I graph the velocity, we'll notice something that we're going to sketch in a little bit. 3x to the power of, is that 4? Ooh. Minus 11x squared plus 9x minus 2. And again, if you're not typing with me, you're graphing in your head. Okay, I'm gonna call on you. All right, I will go to Zoom 6 just to kind of be safe, and then we'll see if we need to expand it or not. And actually, do we see the endpoints basically?
Yeah.
So I think Zoom 6 is pretty much good enough. Let's see.
What does Zoom 6 do again?
It makes it 10 by 10.
Okay, okay.
Mm-hmm. So let's sketch this graph. So this graph is doing, ooh, just gonna
Really big.
exaggerate on some parts and some I'm not going to. So here I have my graph. So particle is going to change direction when the velocity changes sign from positive to negative, or it's going to be negative to positive. So let's see. At this point, Would you agree we have a positive and a negative right here? Okay? At this point right here, don't we have that negative and a positive? Now, at this point, am I changing sign? They're all under, okay? Or at 0. So for this one, we're looking at how many locations? 2.